folks, Ms. Gosling here. It's time to talk about how we graph traveling waves. By the end of the video, you will be able to interpret graphs of traveling waves. So let's go ahead and get started. By talking about displacement versus distance graphs. So what displacement versus distance graphs do, we've got displacement on the y-axis, distance on the x-axis. Our displacement versus distance graph looks at a snapshot of the wave at a single point in time, and we can use it to figure out the wavelength of our wave, the amplitude of our wave, and that's kind of really about it. We can figure out the height of a trough, or the height of a crest or the depth of a trough, but really it's about wavelength and amplitude. So we can see here the length of my wave is going to start at this point here, and wow, you guys, I am really having some trouble with drawing. Let me try that one more time. So again, we're starting here at our high point, and we can go through one full cycle. So we're going to go watch our wave as it goes down through a trough, and then back up to our next crest for one full wavelength. And we can read off of our graph the length of our wave by looking at the difference between our initial position and our final position. That's going to be our lambda. Now, just so you guys know, if I wanted to start my wavelength, for example, here, I could do that too. And for that, I would have to go through one full trough, or one full crest, one full trough, and then back to the start. So again, I'm still going through one full cycle to get my wavelength. I could also go from trough to trough, but there's not a good way to show that on this graph. I could also go from really any random point to any other random point as long as I went through a full wavelength. So again, that's how I'm going to find the wavelength of my wave. So I can only find that on a distance displacement graph. I'm not going to find that on the next kind of graph we're going to talk about. So the other thing that I could find on this graph is my amplitude, and that's going to be the distance from from the x-axis to the highest point on my wave, or the distance from the x-axis to the lowest point in my wave. And that is going to be my amplitude. And again, I can read that on a displacement versus distance graph. Now, just like how I can read my amplitude on a displacement distance graph, I can actually also read it on the second kind of graph, which is a displacement versus time graph. So our displacement versus time graph is going to be looking at one point along the wave's path, and we're going to look at how that point changes in its energy over time. So the amplitude is still going to be the distance from our x-axis to our highest point. However, instead of being able to measure our wavelength easily, we're going to actually have an easier time finding our period by starting at a crest, going all the way down through a trough and back up to our crest to get one full cycle. So again, while this was lambda in my displacement versus distance graph, it is now my period. So I could also pretty easily calculate frequency, right, by doing 1 over my period. So I can see so I can do my period looking at those 2 points. I can also start at 0 and go through, again, one full cycle back up to 0. And again, that is also going to be one full period, which, as you can see on my graph, is 0.4 seconds. And I can see that by looking at the distance from 0, 0 to 0.4, or from 0.1 to 0.5, that time. I can also use that to find my frequency by saying that my period is equal to 1 over my frequency. Thus, my frequency is equal to 1 over my period, or 1 over 0.4 hertz. I could also finish solving that out. I'm not going to do that right now, though. So those are kind of the things that I can easily find in my displacement versus time graph. So to reiterate, in my displacement versus distance graph, I can find my wavelength, my amplitude, and the height of my crest and the depth of my trough. In my displacement versus time graphs, I can also find my amplitude and my crests and my troughs. But instead of the x values helping me find my wavelength, they'll help me find my period and thus my frequency. So very quickly, let's talk takeaways. First of all, if you see a graph of a wave, it's very important that you start by checking whether it's displacement versus distance or displacement versus time. So take a look at that x-axis to see what you're actually looking at. Second, our displacement versus distance graphs help us find wavelength, and our displacement versus time graphs help us find period or frequency. So there you have it, folks. Now you know how to interpret our wave graphs. Best of luck and happy solving.